Hi, I'm doing Paul McWhorter's Raspberry Pi lessons, and this video is covering his lessons 46 to 48, which is to do with using OpenCV on the Raspberry Pi. I'm using VNC to connect to the Raspberry Pi. I'm using a Raspberry Pi 4, and the first program is just displaying how many frames per second I'm getting from my camera. So I'm just setting up a number of frames counter and starting the time. So every 10 frames I'm working out how many frames per second I'm getting. So it's all very simple. So we'll run that and I'll move that over, and up there in pink I'm getting 24 to 30. 25, 30 is kind of jumping around a bit because of joggling, I should think. And please note the text is the same colour as the teddy, which is attention to detail. Right, we'll get out of that program. My next program, I just thought I would draw some shapes, and I'm drawing, I've still got the frames per second up there. And then I'm just drawing a rectangle as Paul drew. Then I'm drawing a circle that will increase and decrease in size, and then I thought I'd just draw a triangle. This line here, if not C min rad blah blah blah, is quite interesting. I will just show you what it's doing. I like this construct in Python. If you go 1 is less than 5 is less than 8, like that, it comes as true, because 1 is less than 5 and it's less than 8. And you can even go 4 is less than 8 is greater than 2. Yep, that's true also. Or if you go 1 is less than 4 is less than 2, that's false, because 4 is not less than 2. And you could also go not bracket 1 is less than 6 is less than 9, like that. False. I really like that. Anyway, back to the program. So that's what it's doing. It's just checking whether the radius is within the minimum and the maximum allowed radii, and then it reverses direction if it gets too big or too small. So we'll just run that. The teddy doesn't flinch, which is good. And there's just the triangle I drew. Right. Then, after I wrote my program for the bouncing box problem, I looked at Paul's solution, and then I looked at everyone else's solutions that had been posted, and I realised that everyone had done something rather differently to me. So we'll look at Paul's program first of all. Now, when I first looked at it, two things jumped out at me. I'll put the value back to how it was. First of all, he's setting up his box with the top right-hand corner, top left-hand corner, and then to get the bottom right-hand corner, he adds the width and the height to the coordinates. Now, if you do that, your box is too big. It's one too big. And I noticed that everyone that I looked at was doing kind of the same thing, apart from Keith. Keith caught that. He took -1 off it, because if you want a box width of 250 and you do that, it'll be 251. And then also making delta C and delta R the same value makes testing very difficult, because if you did a typo, you wouldn't actually notice. Now, going down here is all the guts of the program, so we'll just run it and see what happens. All seems okay. Now that doesn't look quite right to me. I don't think it is hitting the side of the box at all. So I wanted to do a bit of investigation. So if I make delta C slightly bigger, if I make that 5, and we'll run it and we'll see what happens. No, it doesn't look quite right. So if you look at this, if the left hand column plus delta C is less than 0, or the right hand column plus delta C is greater than the width of the display minus 1, in fact if it's over there, then you go into reverse. But that doesn't take, that just means that if you get within that far of the edge, you go in reverse. You don't go to the edge and bounce and come back. I can show you what I mean. If I've got this print statement in there to see what's happening. So if we run the program, and the same thing happens with the rows as well. So if we run it again, and we stop it when it's just bounced on the right hand edge. Right. If these figures, I will make them a bit bigger so we can read them. There, that's okay. Go down to the bottom. What we're interested in is the lower right columns, where that changes. Right, that you can see they're going down there, so it means that's on its way back. So if we go back to where it changes over, right, this is before it bounces. It goes 40, 45, 50, 55, 60, 65, 70, 75. Now, it ought to go 76, 77, 78, 79, oh, back. So it ought to bounce, but instead it says, oh, I'm going to hit the edge, cripes, I'll just slam myself into reverse. Now, that isn't what you want to happen at all. So that is the fault in this program. And I looked at everyone else's programs and everyone else did the same thing, which was a bit weird. Right, so if we look at my solution, I want to get the text size down again. Go up to the top. Nothing of import really, nothing of import. First of all, I'm checking to see whether the width, whether the box is actually smaller than the screen, because otherwise it wouldn't be great, would it? And I've put that at the top of the while loop just in case in the program I decided to ever change the size of the box. So originally I thought whenever I'm moving the box, I would say, has it bounced? And then if it goes beyond, say if it went 3 pixels over the edge, I'd make it go back by 3 pixels. But then I thought this could have problems if you're going really fast, or if you had a really big box in comparison to the screen size. It might want to bounce off one side and then bounce off the other just in one screen display. So I thought I would actually step through the increase. So that's what this does here. I put 4 underscore because I don't actually need the counter that I'm using. So that is the position of the top left x coordinate of the thing. So I'm adding on 1. No, I'm not. I'm adding, well, when it first starts, I'm adding on 1, which is drx, which is 1. And then I'm checking to see whether that is within the confines of the screen. And if it isn't, I change direction. So when it gets to position 0, for example, or it gets to the last position, it's okay, but then it will change direction, so next time it's coming back. And I do the same thing on delta y. So if it goes up, if it gets up to 0, I change direction, or if it goes to the bottom thing, it changes direction. And then I don't do anything until I've gone through delta x times, so that it means that I know the value of the coordinates, but I'm not displaying until at the end, and it seems to work fairly well. So we'll try that. And you'll see that it doesn't actually get to the edge sometimes. Quite difficult to see, but it might be one off, because if you're 1 off the edge and then you're going forward by 2, you'll be bouncing. And this is my solution to the bouncing box, as opposed to the cripes, I'm going to hit the edge of the screen, I'll go into reverse box. So there we have it.